Exponential equation, shall we? By solve, we want to find what x equals. So 2 raised to what equals 5. I think you'll agree that x is not going to be a very nice number. It's certainly not going to be a whole number. Might even be an irrational number. What do you think?
I think it might be.
So if you remember, we solved exponential functions using logarithms. And why is that?
Because logs are just exponents?
You got it. Logs are exponents. So there are 2 ways to do it. You probably learned both ways last year. Let's just try one of the methods, which I'll call method 1, very original name.
I like to call it method A myself.
That's fine.
But is that the same thing?
Excellent.
Right.
So method 1 involves rewriting this exponential equation in logarithmic form. So we have to remember the definition of a log. If you have some number raised to an exponent and it equals some number, you can rewrite that in logarithmic form as the log of the base, okay, log base b of the number equals the exponent. These are interchangeable. They're 2 different ways of writing the same expression. I'm sure you remember that from last year or earlier this year. So let's use that to rewrite this in logarithmic form. So that's going to be log base 2 of 5 equals x. I just rewrote that in logarithmic form. Now you can use your calculator. If you have the new software, you can put that right in your calculator. If you don't, then we need to use the change of base formula, which if you remember is the log of the number, log of 5 in this case, divided by the log of the base. And that equals x. That little guy, you're just going to throw in your calculator. Blah, 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 blah. Hey, it is some irrational number. I'm just going to round it to, let's do 4 places. 3, 2, 1. Blast off. No, 3, 2, 1, 9. Round it to the nearest.
Now, you're pretty quick with that calculator.
Yeah, see?
Through the magic of television, you had it already in there.
I did.
Yeah. Very nice.
Giving away all my secrets. So let's solve that same equation using a second method, method 2. Mr. Haas, you might think of that as method B.
Method 2 or B, that works, yeah.
So we're going to solve it again, but just using another method. Now, this method involves one of the rules or properties of logs. You remember all those things? Like when you're taking the log of something times something, it's the same as log of something plus log of something. Log of something divided by something is log of something minus log of something. Okay, the property we have to remember is if you have some number raised to an exponent, that can be rewritten as b times the log of a. Okay? Since logs are just exponents, you're multiplying together the 2 exponents. All right, so keep that property in mind. So what we're going to do here, oh, I forgot, the other property that you have to remember, which I always called the duh property, was if A equals B, then the log of A equals the log of B. All right. We're going to use those 2 properties to solve this 2 to the x equals 5. Here we go. I'm going to first take the log of both sides. The log of 2 to the x equals the log of 5. I'm not writing any base there. It's just base 10, common log. Now I'm going to use this property. I can bring that x down. X times the log of 2 equals the log of 5. And I'm going to bring this on over here. I think you can all predict what I'm going to do to get x by itself. I'm just going to divide both sides by the log of 2. So I have the log of 5 divided by the log of 2. Hey, that's looking kind of familiar to me. X equals 2.3219. Of course, you would need your calculator or your parents' log tables from when they were kids to figure that out.
Staying alive, staying alive. Staying alive.
It looks like an exponential equation.
It
so
does,
that's
and
solid.
pretty much for me the clue is if I have an x in the exponent, I pretty much know I'm going to need logs to solve this guy, solve this bad boy, as you would say. That's okay to say, right? All right.
It is.
Would you say that?
I would.
Okay.
I think I picked that up from you.
The first thing I'm going to do is see if I can get this guy by itself. So I'll just divide both sides by 2, and I think I can even do that in my head. I have 3.4 to the 3x. I really don't even need the parentheses anymore. If I divide both sides by 2, 500 divided by 2, I think it's 250. So far, so good.
Very nice.
And I'm going to use Ms. Stewart's method 2, where I'm going to take the log of both sides. So that is just log. And again, if you don't write anything there, it means log base 10, of course, equals log of 250. Log both sides. Now I'm going to use that rule where log of some number raised to some exponent is the same thing as that exponent. I'll just bring it down in front. 3x times log of 3.4 equals log of 250. I'm getting there. And now, well, I could do this in one step actually, but let's do it in 2 steps. What do you think, Ms. Stewart? Would you do it in 2 steps? I'm going to divide by log of 3.4. So I have 3x equals log 250 divided by log of 3.4. How do I get rid of the 3? I'm just going to multiply both sides by 1/3, of course. That's 1/3. So x equals this whole business. Now, of course, I could punch that in my calculator, but I don't even think I'm going to do that. I'm just going to leave it in terms of logs. This is log of 3.4 times 1/3. What do you think, Ms. Stewart?
That sounds good. Can you just throw that 3 next to the log 3.4?
Throw this 3. Oh, you want me to write the 3 in
Yeah,
front?
just so it's one expression.
Sure, absolutely.
Wouldn't that be fun?
That would be great. Want me to write it as
Not that it matters.
log 250, 3 times log of 3.4.
Sure, doesn't really matter.
So we decided, what the heck, for those of you guys who are trying this out at home, we would write it as an actual decimal answer. So we punched it in the calculator, and here is the answer rounded to 4 decimal places. I'm doing one more, Ms. Stewart.
Excellent.
So once again, I like to take the log of both sides. Is that all right with you?
I do too.
All right. Is that really how you would do it?
That's totally how
So
I would
I'm
do
going
it.
to take the log of both sides. So I've got the log of this side equals log of 8. Bring this guy down in front here. X plus 2 log 5 equals log 8. Going to divide by log 5. X plus 2 equals log 8 divided by log 5. And now I just have to get rid of that 2. That's not too bad.
Not that
I'm just going
bad.
to subtract 2 from both sides. That 2's gone, so now I have x equals, and if I were to write it in just log form, it would be log 5 minus 2. Through the magic of television, I already have the answer. Should I round it to more decimal places just to be very exciting this time?
Let's be very excited.
All right. How many decimal places does it go to, Ms. Stewart? In
Well, I
actuality?
think that goes on and on and on forever.
707. Tell me when to stop. 03. I think that's
That's
plenty
plenty.
of decimal places. So there it is, rounded to 1, 2, 3, 4, 5, 6, 7 decimal places.
Well done.